What's the robot definition? A robot is a machine designed to perform various tasks autonomously or under the control of an operator. It is typically equipped with sensors, actuators, and a computer or microprocessor that allows it to interact with the physical world and make decisions based on input from its sensors. Robots can be programmed to perform a wide range of tasks, from simple repetitive actions to complex operations that require advanced artificial intelligence and machine learning algorithms. They are used in a variety of fields, including manufacturing, healthcare, transportation, service industry, and entertainment. Assembling small parts into larger units is a crucial part of the manufacturing process. Previously, the combination of human dexterity, vision, and intelligence was the only way such assembly could be done. Recent advancements in technology have now made it possible for robots to do many of these tasks. Since many assembly processes require adhesives, robots that can dispense bonding agents are a related technology. The automotive industry was one of the first to adopt industrial robots for assembly. Today, assembly robots are found in applications far beyond automotive. There is a growing need for high-speed, robotic assembly of small parts. The accuracy and speed of robotic assembly often mean higher throughput and greater precision than can be achieved using human labor. Adhesive dispensing robots. A dispensing robot applies adhesives and sealants in a variety of applications. These can include fastening pieces together, encapsulating pieces in a sealant, and many more. Smaller jobs such as glue and epoxy dispensing call for a compact, high-speed robot. Larger applications, often seen in the automotive industry, use a heavier payload robot. Handling and picking. Robots that transport goods within a warehouse, or that pick items out of a tote and place them into a shipping container, are examples of handling and picking robots. With the rise of e-commerce, there is a large and growing demand for robots that can pick and fulfill orders. Material handling robots. In warehouses and in factories, one of the most common tasks is transporting goods. Studies have shown that many industrial operatives spend most of their day walking, pushing a cart, or driving industrial vehicles like forklifts. These activities represent a low value added, and therefore are a good candidate for automation. Material handling robots. Self-driving forklifts have become increasingly popular. Not only is there a benefit in reducing the labor required to transport goods, but there is also a question of safety. Every year there are hundreds of deaths related to forklifts and thousands of injuries associated with this material handling equipment worldwide. Self-driving forklifts employ a variety of sensors that enable them to prevent accidents. Liquid handling robot. Testing of medical samples, analyzing the chemical composition of liquids, and biological experimentation are three applications that require daily, repeated pipetting. Pipetting is the process of suctioning a small amount of liquid into a syringe and transferring precise quantities of the liquid into a second receptacle. Laboratory and medical technicians can spend hours daily performing pipetting. It is a repetitive and manual process, in which it is easy to make mistakes. Pharmaceutical companies need to dispense precise quantities of liquids into containers to produce eye drops, nasal sprays, and a large variety of liquid medications. Liquid handling robots can automate these processes, resulting in higher throughput, greater accuracy, and improved traceability. Pick-and-place robots. This is perhaps the most common application of robots in manufacturing. These robots can load and unload processing machines, take parts from a conveyor line and put them into totes or shipping containers, and sort parts from randomness to an ordered format. This kind of robot is generally used when the number of variables is small. For example, the same kind of part comes down an assembly line, and it needs to be placed into a tray, or stacked, or ordered. Laser cutting robots are robotic systems that use high-powered lasers to cut and engrave a wide variety of materials such as metals, plastics, and wood. These robots are equipped with a laser cutting head that directs the laser beam onto the material surface, heating and vaporizing the material to achieve precise and accurate cuts or engravings. Some materials are difficult, or even impossible to cut without using lasers. Indeed, the first laser cutting machine used in production was to drill holes in diamond mold. Plasma cutting robots. Plasma cutting evolved from plasma welding, starting in the 1960s. By the 1980s, it became an effective way to cut sheet metal and steel plates. Plasma cutting has advantages over more traditional, abrasive metal-on-metal methods. It does not produce metal chips and creates more accurate cuts with a cleaner edge. However, early plasma cutting machines were generally confined to cutting sheet material, as the CNC only allowed for movements in two directions. Robotic plasma cutting systems can offer 6 degrees of freedom movement, 4 very flexible operations, and the possibility of complex cuts. Plasma cutting robots are robotic systems that use a high-velocity jet of ionized gas, plasma, to cut through electrically conductive materials such as steel, aluminum, copper, and brass. The plasma cutting process involves the robot directing the plasma torch to the material surface, which ionizes gas and creates a high-temperature plasma arc that melts and cuts through the material. Water jet cutting robots. A water jet cutter, as the name implies, uses a powerful, high-pressure jet of water to cut a wide variety of materials. Because the nozzle can be made as small as 0.002 inches, 0.051 millimeters, a water jet cutter can perform high-precision cuts including circles and sharp internal angles. For softer materials like plastic, rubber, and wood, a high-pressure water jet is sufficient. For harder materials such as metal, stone, or glass, an abrasive material can be added to the water jet. One of the advantages of water jet cutting is that there is no heat-affected zone, an important consideration for some kinds of materials that tend to warp and deform under the influence of heat. Water jet cutting robots are machines that use a high-pressure stream of water to cut through various materials, including metals, plastics, ceramics, and composites. The process involves forcing water through a small hole at a very high pressure, typically 60,000 psi, pounds per square inch, or higher, to create a narrow stream of water that can cut through even the toughest materials. In some cases, abrasive materials such as garnet or diamond may be added to the water to increase its cutting power. Water jet cutting robots are typically computer-controlled, which allows for precise and intricate cuts to be made with a high degree of accuracy and repeatability. The robots can be used in a wide range of applications, including manufacturing, aerospace, automotive, and architecture, among others. Implies, implies. High-pressure jet of water, high-pressure jet of water. Nozzle, nozzle. Sufficient, sufficient. Abrasive material, abrasive material. Heat-affected zone, heat-affected zone. Warp and deform, warp and deform. Ceramics, ceramics. Composite, composite. Abrasive materials, abrasive materials. Garnet or diamond, garnet or diamond. Precise and intricate cuts, precise and intricate cuts. High degree of accuracy, high degree of accuracy. Repeatability, repeatability. Aerospace, aerospace. Architecture, architecture. Arc welding robots. Arc welding joins metal pieces together by using electricity to heat the metals to their melting point. When the melted metals cool, they are permanently joined, and the joint is airtight. Arc welding is flexible, allowing for flat sheets, tubes, and rods to be joined together, and the weld can be located anywhere along the surface of the workpiece. In addition, arc welding can be used with a variety of metals, including copper, aluminum, and copper alloys. Arc welding can be performed outdoors. Because the process involves high temperatures, the welder must wear eye protection, special gloves, and other protective gear. Arc welding robots, arc welding robots. Melting point, melting point. Permanently joined, permanently joined. Airtight, airtight. Aluminum, aluminum. Copper alloys, copper alloys. Protective gear, protective gear. Finishing and sanding. Many industrial processes such as drilling, casting, die casting, and welding leave unwanted material behind or create ragged or sharp edges. This unwanted material must be removed in order to achieve the desired finished product. This is the job of finishing and sanding. Logistics and storage. Warehouse robots. Robots that operate in a warehouse or distribution center can be used to automate a wide variety of tasks, including order picking, packing, sorting, labeling, and transporting. Delivery robots. Delivery robots are commercially available in a variety of shapes and sizes, and for different functions. Some delivery robots are designed to deliver food in a city environment and look like carts with wheels. Other delivery robots look like humans because they walk on two legs and have arms, and the head is replaced with a dome full of sensors. There are unmanned aerial vehicle, UAV, delivery robots that can fly packages to the customer and drop them off. And there are four-legged delivery robots that look a little bit like dogs. Self-driving vehicles are in limited use in certain areas that are deployed as delivery robots. In all cases, the advantages to delivery robots are many, including speed of delivery, lower labor costs, and reliability. Commercially. City environment. Dome. Unmanned aerial vehicle. Limited use. Deploy. Self-driving vehicles.